Section 7-4 is about similarity in right triangles. If you draw in the altitude of a right triangle to the hypotenuse, what you actually have created are three similar right triangles. Okay, so in this picture, CD is the altitude. Okay, and I've created three triangles, a small one, which is this one right here, also drawn down here in blue. There is a middle one, which is drawn down here in green, and there's the overall one. Okay, let me briefly explain why they're similar using the ideas we talked about in section 7.3. Okay, the small triangle has a right angle at D, and the big triangle has a right angle at C. Okay, they both also share angle A, which is congruent to itself by the reflexive property. So these two are similar, meaning the small one and the big one are similar by the angle-angle postulate. Okay, similarly, in the middle triangle and the big triangle, they both have a right angle at C, and then the middle one has a right angle at D, and they both share angle B. So angle B is congruent to itself by the reflexive property. So these two triangles are similar by angle-angle. Okay, now I hope it makes sense that if the small one is similar to the big one, and the big one is similar to the medium one, that all three are similar to each other. Okay, by using the angle-angle postulate. Okay, now let's look at this diagram. I have drawn in lots of lengths. Okay, and I'll just show you the three triangles that are in this design. Okay, I have the big triangle, I have the medium triangle, and I have the little triangle. Okay, and then I'm going to orient these so they look similar. I think it's easiest for us to do it that way. Okay, and I will draw on the lengths from the diagram above. So in the hypotenuse, in the largest triangle, which is the overall triangle, this one, the hypotenuse is 50. The shorter leg is 22.36, and the longer leg is 44.74. In the medium triangle, which is this one, the hypotenuse is 44.74, and the shorter leg is 20, and the longer leg is 40. In the small triangle, which is this one right here, the hypotenuse is 22.36. The shorter leg is 10, because 50 minus 40 is 10. And the longer leg is 20. Okay? Now you're welcome to go ahead and calculate some scale factors or look at some ratios, but these are all proportional to each other and they're all similar to each other. Now let's write a similarity statement that relates the three right triangles in this diagram. Okay, now one way of doing this is by drawing out all three triangles like I did in the last slide. So here is the largest one. Although they're similar, my picture may not be perfect. Okay, so I have the large, middle, small. Now in the largest triangle, let's see here, the right angle is at K. If I go along the shorter leg, I have L, and then along the longer leg is J. Okay, so I'm kind of thinking of it as starting at K, going to the shorter leg is L, and then going to the longer leg is J. Okay, looking at the medium triangle, the right angle is at N. If I go along the shorter leg, I get K. If I go along the longer leg, I get J. Finally, looking at the smallest triangle, the right angle is at N. If I go along the shorter leg, I get L. The longer leg, I get K. All right, now I've drawn these with the same orientation. Okay, so now that they're all oriented correctly, I can now write a similarity statement. Okay, and the order must be the same for all three. So I will just pick the order of triangle L, K, J. I'm going this order, so I'm going kind of making the L is similar to this L ordering. K, N, J is similar to triangle L, N, K. Okay, and these are all similar to each other. Okay, another way of writing the similarity statement, which I believe is a little faster, and some of you I think are ready to do this, um, is just by kind of thinking through an ordering and walking around each triangle. Okay, so the ordering I will use is I will go along the shorter leg, then along the longer leg. Okay, so in this triangle, the big triangle, it is triangle LKJ. In the medium triangle, again, the ordering must be the same. I go along the shorter leg, then along the longer leg. So it's triangle KMJ. Okay, that's similar to. In the smallest triangle, I will go along the shorter leg, then along the longer leg. Triangle LMK. Okay, now that's one way of doing it. It's, it takes a little more thinking, and there's more chances for error, but it is a faster way. So if you can master that way of doing it, by all means use it. Okay, we need to switch gears a little bit and talk about something called the geometric mean. Now, before I discuss the geometric mean, I want to take a step even further back and talk about what you usually call the average. Okay, and another name for the word average is the arithmetic mean. Okay, the average or the arithmetic mean of two numbers. For example, the numbers 2 and 18. Okay, so 2 and 18. The average of 2 and 18 is 2 plus 18 divided by 2. 2 plus 18 is 20. Divided by 2 is 10. Okay, now why is 10 the average? Well, it's right in the middle. We've discussed this previously when talking about midpoints. Okay, but another way of looking at the reason why 10 is the average or the arithmetic mean is in terms of a sequence. So write down these numbers 2, 10, 18. You'll notice that I can get from one to the other by adding the same number, by adding 8. And from 10, I can add 8 again and get 18. Okay? Now, that leads us into the geometric mean. Okay? Because in terms of a sequence, and I'll just find the geometric mean of 2 and 18 to show you how it's different. I will be multiplying by some number, and then multiplying by that same number and getting 18. Okay, now it's really hard to think about that as far as what it might be. And so I will explain that the geometric mean is what you get when you solve this proportion where a and b are the numbers. Okay, so if I use 2 and 8, 2 over x is equal to x over 18. And I'll solve this by cross multiplying. X times x is x squared, and 2 times 18 is 36. Okay? And then I can solve for x. Let's see here. X is currently being squared. To get x by itself, I have to undo or do the opposite of squaring, which is the square root. So the square root of x, take the square root of both sides. X is equal to 6. Okay? So the geometric mean of 2 and 18 is 6. And if I put 6 in here, we'll see that we can multiply by 3 again, and get 18. Okay? So this proportion is really helpful to us in finding the geometric mean. Okay, now before I move on, let me also briefly say that a shortcut to finding the geometric mean, just like we talked about the shortcut of adding them together and dividing by 2, the shortcut for finding the geometric mean is where you multiply them together and then take the square root. Okay, so what is the value of x, which also happens to be the geometric mean of 2 and 8? Now, I will first do this by setting up a proportion, and I will look at the ratio of the shorter leg over the longer leg. Okay, so the shorter leg over the longer leg in the small triangle is 2 over x. In the medium triangle, the shorter leg is x, and the longer leg is 8. okay, which is that same proportion we looked at in the last slide. I'll cross multiply. X times x is x squared. 2 times 8 is 16. I'll find what x is by doing the opposite of squaring, which is square rooting. And x is equal to the square root of 16, or 4. Okay, again, 2 times 8 is 16. Square root of 16 is 4. And so x is going to be 4. Okay, let's try this in another problem. I'll first find y, and yes, I could multiply 4 and 12 and take the square root, but I'll write down the proportion just for the practice. I will look at, in the smaller triangle and the medium triangle, I will look at the shorter leg over the longer leg. So in the small triangle, the shorter leg is 4, the longer leg is y. In the middle triangle, the shorter leg is y, and the longer leg is 12. I will cross multiply. Y times y is y squared. 4 times 12 is 48. So to undo a square, I take the square root. Y is equal to the square root of 48, which is approximately 6.93 is y. Okay, now let's find x. Okay, x is located on the median, on the small triangle and on the large triangle. And I will see, the only information I know about both of these triangles is the shorter leg and the hypotenuse. So the ratio I'll look at is short over hypotenuse. Okay, on the smaller triangle, it is x over 4. That's not correct. The shorter leg is 4, the hypotenuse is x. And on the big triangle, the biggest triangle, the shorter leg is x, and the hypotenuse is 12 plus 4, or 16. So I will cross multiply. X times x is x squared. 4 times 16 is 64. I will undo the square by taking the square root, and I get 8. Okay, I hope that's helpful. This problem is similar to the last ones. I'll skip it. This one as well. Well, I'll do this one since it's, you see a second example. Okay, to find y, I will look at short over longer leg. So it's 6 over y is equal to, now in the medium triangle, the short is y, the longer is 14. I won't solve it. I know that you're good at solving them, but this would give you y. To find x, I would look at the hypotenuse and the shorter leg of the small triangle and of the big triangle. So I look at short over hypotenuse, and the short leg is 6. The hypotenuse is x on the small triangle, that's this one. And in the big triangle, the short leg is x, and the hypotenuse is 6 plus 14, which is 20. And I would solve this proportion to find x. Okay, so what is the geometric mean of each pair of numbers? Okay, I'm going to use the shortcut of multiplying them together and taking the square root. So it's a square root of 4 times 9, which is a square root of 36, which is 6. Okay, now you still could solve the proportion of x over 4 is equal to 9 over x. Number 2, the geometric mean of 4 and 12 is the square root of 4 times 12, or the square root of 48, which is 6.93. All right, use the figure down here to complete each proportion. G over E, let's see here, that's the small triangle, and it's short over long. G over E is equal to E. Now, which triangle has E as the short one? It's the middle one. So the longer leg in the middle triangle is H. Number 4, J and D. J and D are on the biggest triangle. J is the hypotenuse, and D is the shorter leg. Okay, now on which triangle is D the hypotenuse? Well, it's the hypotenuse on the shortest um, triangle. So the short side of the small triangle is G. Number 5, um, blank over F equals F over blank. Okay, now which two triangles is F in? Well, F is in the large triangle, the biggest triangle, and the medium triangle. Okay, so I will think about this as the large proportion, the large ratio, this as the medium proportion. Now in the large proportion, now let's see here, what in the large triangle, I'm also going to be looking at E, okay, because that is in, okay, sorry about that. Um, Now, in the large triangle, F is the longer leg. So that must be on the bottom. And in the medium triangle, F is the hypotenuse. So the ratio we're looking at is hypotenuse over longer leg. Okay? In the large triangle, the hypotenuse is J. And in the medium triangle, the longer leg is H. So the ratio is J to F is equal to F to H. Okay, number 6, we're looking at J and G. Okay, now J is a hypotenuse. Okay, and G is a shortest leg, shorter leg. Okay, so the ratio must be hypotenuse over short is equal to hypotenuse over short. Now, J is the hypotenuse of the big triangle. So this is the big triangle. It's the small triangle. So what is the short side in the big triangle? Well, the short side in the big triangle is D. And in the small triangle, the hypotenuse is also D. Okay, so looking at the big and the small, and it's the hypotenuse over short is the ratio we're looking at. Okay, that wraps up our discussion about similarity in right triangles.